Hello fellow students, today we're going to learn about covalent bonds in giant structures. To fully understand covalent bonds, we first need to look at molecules and compounds. Molecules are two or more atoms joined together chemically, whilst compounds are two or more atoms of different elements joined together chemically. So all compounds are molecules, but not all molecules are compounds. If we look at H2, for example, we see only one type of element. So it is a molecule, but it is not a compound. If we take a look at H2O, there are two different types of elements inside the molecule, and therefore it is a compound. The two examples before were examples of covalent bonds. A covalent bond is a bond between two non-metal atoms. They combine by sharing their valence electrons. This means that a covalent bond can appear in both molecules and compounds. The bond between the atoms can be a single, double, or triple bond. The greater the number of bonds, the shorter the bond length, the stronger the bond is. The kind of bonds that will form between the atoms depends on how many electrons are needed to achieve a full outer shell. For example, methane is a covalent bond between carbon and hydrogen. Carbon originally has 4 electrons in its outer shell, while hydrogen originally has 1. Hydrogen wants 1 electron to fulfill their valence shell, whilst carbon needs 4 electrons to fulfill their valence shell of a complete 8. So they can all fulfill their needs in this methane molecule. Although they are not stronger than ionic bonds, covalent bonds between atoms are quite strong. But when it comes to attraction between molecules, they are usually pretty weak. This means that only a small amount of energy is needed to break the intermolecular forces. On the other hand, giant covalent structures, meaning structures where atoms are covalently bonded in a network throughout the whole structures, are held together strongly. They usually have relatively high melting points and often very strong, especially in the case of diamonds. This is because each carbon is covalently bonded with 4 other carbons in tetrahedral shapes throughout the whole structure. However, in graphite, the carbon atoms are connected in hexagonal sheets that are held together by intermolecular forces between the layers. This is why when you put pencil to paper, the sheets peel off onto paper, and thus you have writing. To see if you have been following along, here are some questions. Here's your first question. Hydrogen peroxide, which is covalently bonded, has the chemical formula H2O2. But is it just the molecule, or is it the compound? Hydrogen peroxide is both a molecule and a compound, because there are numerous atoms joined together. The atoms are also different elements, hydrogen and oxygen, meaning it's also a compound. Here is another question. Which of these compounds are covalently bonded? The answer is that all of these are covalently bonded, because none of these elements are metals. Here is another question. Name 2 characteristics of a giant structure. Well, the answer is, if we look at the 2 worked examples from before, graphite and diamond, they both have very high melting points. But on one hand, the diamond is very strong. It is the strongest mineral known to man. But graphite is very weak. It is because diamond is solely held together by strong covalent bonds, whilst graphite is held together by weak intermolecular forces. This video was made by Elizabeth, Elin, and me, Gabriel. Thank you. Hello fellow students. Molecules.